Let's solve problem 16-135. At the instant shown, ball B is rolling along a slot at the velocity of 6 millimeters per second. Let's change that to 0.6 meters per second. And the acceleration of 150 millimeters per second squared. So let's change that to 0.15 meters per second squared. Both measured relative to the disk and directed away from O. So it's going in the positive x direction. At the same instant, the disk has an angular velocity and acceleration of 6 radians per second and 3 radians per second squared. Determine the velocity and acceleration of the ball at this instant. So let's start with the equation. VB is equal to VA plus omega plus RB with respect to A plus, oh, that's not plus, that's cross, plus VB with respect to A in the XYZ plane. And these are all vectors. So VB is what we're trying to find. The velocity of the ball that someone outside observes. VA is the velocity of the origin of the XYZ reference measured from the outside frame. So that is the speed at which the origin of this is moving. Now this one is just spinning. It has no linear velocity. So that is 0. Okay, and then omega is the angular velocity of the XYZ reference, that's smaller XYZ reference, measured from the capital XYZ. So how fast this is spinning. So in this case it's 6 radians per second in the positive k direction. And then VB with respect to A is the velocity of B with respect to A as measured by an observer attached to the rotating. So someone on this is watching how fast is it moving out. So that V would be 6.6 meters per second. And that would be in the positive I direction. So substituting this into the equation, oh, we missed R. So RB with respect to A is the position of B with respect to A. So the distance there, which is 0.4 meters in the I direction. So putting everything into the equation, we get VB is equal to 0 plus 6 in the K direction crossed with R, 0.4 in the I direction plus 0.6 in the I direction. Performing this cross product here results in 2.4 in the J direction. So VB is equal to 0.6 in the I plus 2.4 in the J. Now, solving for acceleration, we get the monster of all equations. A plus omega dot cross R B with respect to A cross omega cross R BA plus 2 omega cross with V B with respect to A in the XYZ, that's smaller XYZ, plus A B with respect to A in the XYZ. And these are all vectors. So we've already defined these, so let's go on to define AB is the acceleration of B with respect to, as observed by the outside frame. And that's what we're trying to find. AA is the acceleration of the moving reference frame. In this case, the acceleration is 0 because it's stationary. Then let's define omega dot, and that is the angular acceleration of the rotating frame. In this case, 3 radians per second squared in the positive k. Next we have A, B, A, which is the acceleration of the object within the reference frame. So it's 0.15 meters per second squared in the positive I direction. Substituting all that into there, we get AB is equal to 0 plus 3 in the k crossed with 4 in the I plus omega 6 in the k crossed with parentheses 6 in the k crossed with RBA 0.4 in the I plus 2 omega 6 in the k, that's multiplied, crossed with VB with respect to A 0.6 in the I plus ABA 0.15 I. Let's start by performing the cross products. This cross product is 1.2 in the J. This cross product is 2.4 in the J. And this cross product is 7.2 in the J. We have to bring this down. 6 in the K crossed with 2.4 in the J yields negative 14.4 in the I. So AB is equal to let's do the I's. That minus that is a negative 14.25 in the I and plus 8.4 in the J.